In this video, we will analyze the meaning, cause, and solution of the protection code P1 in TCL air conditioning units. When the P1 code appears on the display, the cause is usually overvoltage or undervoltage protection. However, as we will see below, it is advisable to follow the steps to resolve the P1 code, as the cause may vary in TCL units. 1. Disconnect the unit for several minutes. Then, turn it back on and check if the P1 protection code reappears. 2. Ensure that the voltage at the supply point is between 160 and 260 volts. Use a multimeter on the AC voltage scale to perform this measurement. 3. If the supply voltage is not within the proper range or fluctuates, consider using a voltage protector or changing the unit's power supply point. 4. Verify that the voltage at the air conditioner's input matches the supply voltage by measuring between terminals L and N of the outdoor unit. Ensure it is within the range of 160 to 260 volts AC. 5. Ensure that the power supply electrical connections are firm and in good condition. 6. If everything seems to be in order, check the outdoor unit's electronic board. Perform a visual inspection of the high-power electrolytic capacitors. If you detect any defects, they should be replaced. 7. Measure the voltage at the rectifier bridge output. For units powered at 220V, the voltage should be close to 320 volts DC. Use a multimeter on the DC voltage scale to perform this measurement. 8. If you haven't found the fault yet, disconnect the outdoor electronic board and measure the reactor's resistance using the multimeter on the ohm scale with the reactor disconnected. Compare it with the manufacturer's recommended value. 9. Check the state of the fast diode. Remember that a diode allows current to flow in only one direction. Use a multimeter on the diode scale with the electronic board disconnected to check it. 10. Test the IGBT transistor. A. Disconnect the transistor from the board and locate the IGBT pins, gate, emitter, and collector. B. Set the multimeter to the diode scale. Test between collector and emitter. Place the negative lead on the collector and the positive on the emitter. The multimeter should show infinity or very high resistance. Then reverse the leads, positive on the collector and negative on the emitter. The multimeter should still show infinity or high resistance. C. Gate activation test. Place the positive lead on the gate and the negative on the emitter for a few seconds. Then, without touching the gate, measure again between the collector and emitter, negative on the collector and positive on the emitter. If the IGBT works correctly, there should be conduction, low resistance, or a few millivolts. D. Deactivation test. Place the negative lead on the gate and the positive on the emitter for a few seconds. Measure again between collector and emitter, and the multimeter should show infinity or high resistance again.